welcome to the deep dive. Today we are tackling a really fascinating engineering problem.
It's a big one.
It really is. I mean, how do you take 8 separate, just massive feeds of pristine, uncompressed broadcast video and get them ready for distribution? Like right now.
And across different kinds of networks, too.
Exactly. Across the internet and traditional networks. The answer, it turns out, is the piece of hardware we're diving into today. The Thor Broadcast H-8HD-EMS.
That's the one. An 8-channel HD-SDI encoder multiplexer and an IPTV server all in one box.
So our mission here is to really move past just the spec sheet and understand the critical workflow impact a single device like this can have. It's like the traffic control system for high-value content.
That's a great way to put it. And when you see that list price, it's around, what, $7,000?
Just under, yeah.
Right. You know, you're looking at a solution built for non-negotiable reliability. This box is the essential bridge. It's taking that highest quality broadcast signal and it's strategically translating it into the efficient, compressed format that modern IP delivery requires.
Yeah, let's unpack that, starting with the ingest.
Right.
We're talking about a massive parallel ingestion capacity here.
8 channels.
8 channels of HD-SDI input.
Mm-hmm.
And this isn't consumer video. This handles up to 3G SDI, meaning it can accept full, high frame rate 1080p 60 programming.
And that level of input integrity is absolutely critical for, say, frame-accurate switching in a live production.
For sure.
And that input capacity immediately tells you why the encoding part is so paramount. You just can't move that volume of uncompressed data anywhere.
It's just too much.
Way too much. So the device uses robust H.264 compression, and what's absolutely crucial is the level of control you get. You can adjust the bitrate for each program independently, anywhere from 0.5 Mbps up to 19 Mbps.
So encoding is where you're really controlling efficiency and, well, costs. What's the strategic difference between using constant bitrate CBR and variable bitrate VBR in a real-world, high-stakes live event?
It really all comes down to the guarantee. CBR gives you a guaranteed, consistent stream size. That is vital for a high-priority live feed where stability is everything. Think of your primary program feed.
Right. Rock solid.
Exactly. VBR, on the other hand, lets the compression engine vary the data rate based on picture complexity. That maximizes your efficiency for, say, less dynamic secondary feeds or for archiving.
So the fact that all 8 channels have independent settings
means a broadcaster can run a whole tiered distribution model all from one single rack unit. It's incredibly efficient.
So we've taken 8, fire hoses video, packaged them perfectly. But where do they go? Let's talk distribution, because this system gives you simultaneous dual outputs, ASI and IP.
And that's the ultimate flexibility. The ASI outputs, that's asynchronous serial interface, that's your traditional digital broadcast backbone.
The legacy stuff.
The legacy stuff, yeah. They're mirrored outputs used for connecting directly to existing broadcast modulators or, decoders on a cable head-in.
So that keeps you compatible with all the installed infrastructure. But the future is definitely in the IP stream.
Precisely. The IP output uses a standard IPTV format supporting unicast or multicast.
Okay, so let's get into that. It manages content using both single program streams -SPTS and multi-program streams, MPTS.
Right. So think of SPTS as individual feeds. They're optimized for things like cloud processing.
Got it. One stream, one program.
Yep. Whereas MPTS bundles multiple channels into a single secure pipe, which is essential for your traditional DVB-T or QAM system.
And crucially, you can customize the metadata. You mentioned the PIDs, the program identifiers.
Absolutely. Those are basically the unique digital address tags you need to track high-value content. This granular control ensures your content arrives correctly labeled and indexed for whatever system is next in the chain.
And when you're distributing live content, uptime is everything. It's literally built into the engineering. The sources mentioned the dual hot standby power supplies. That's not just a feature, it's an insurance policy. It's for those stressful, sweaty palm moments that live engineers know all too well.
It's engineered for zero downtime.
So what does this all mean for you, the listener? Well, this piece of hardware allows a professional organization to take 8 simultaneous HD camera feeds,
8 of them,
compress them intelligently, and then package them for transport across both traditional broadcast networks via ASI and internet-based ones via IPTV. It's the high-fidelity translation tool of the whole digital broadcast workflow.
And that leads me to a final, maybe provocative thought for you to consider.
Let's hear it.
Given that this device provides absolute granular control over all the metadata, the program-specific info, those tracking IDs we talked about, how critical is that precise identification when you're moving high-value, licensed content from a highly secured broadcast studio out into the open, less controlled IP domain?
That's a great question.
I mean, you could argue the metadata here is just as important as the video quality itself.